Happy Ocean Day. I'm Hilary, and my friend here is Beth, and we work for the Science on the Sphere team. And we're going to show you, in honor of Ocean Day, we're going to show you some ocean data sets that really highlight the geologic makeup and geologic activity of this mysterious ocean. Although 70% of our ocean is actually made up of the ocean, we have only explored and mapped 20% of it. So it's pretty amazing, it's pretty mysterious. And here, let's get right to it. So this is SOS Explorer. You can download the SOS Explorer app on your Apple App Store.
That's
or
right.
Your Google Play.
It's free. So there is a lot going on in our oceans. And so what we're going to do is dive below the ocean's surface. So what Hilary just loaded here is an ocean drain. So if we were to pull the plug on the ocean and drain out all the water, this is showing what would be revealed beneath it. So the deepest parts of our ocean are what are going to drain last. So the Mariana Trench is the deepest part. Hilary, if you want to rotate back over there, you kind of can see a moon shape. She's zooming in for us. So this area here where the water's draining last, that's our deepest part. Right at the bottom of that crescent is the deepest point. It's 6.86 miles deep. So as you can imagine, there's some incredible pressure at the bottom of that trench. Hilary, what are other interesting features as we drain the ocean?
Yeah, so the parts that are gray first are the most shallow. And what we tend to see in the shallow areas are areas along the coasts. These would be kind of our continental shelves is what we call those. And then when we get a little bit further out, or a little bit deeper, I should say, we start to see the ridges. So these are called mid-ocean ridges, and this particular one over here is called the MidAtlantic Ridge, this really long line. And I believe it's the longest mountain range in the world. And it stretches.
People don't think of it because it's completely underneath the water, but there it is. As we drain the oceans, we're able to see this ridge cutting its way through the middle of the Atlantic Ocean.
Yeah, absolutely. So we're going to actually move from this ocean drain data set. So that's pretty cool. I like the way that it looks around the United States there. You can see that Florida has some pretty amazing shallow ocean, which makes for good swimming. But we're going to go from this to talk about really the age of the seafloor, because when we pull up the age of the seafloor map, we can really get a sense for how has the ocean floor formed.
What we see, if you can go back to the Atlantic Ocean, along that mid-Atlantic Ocean ridge that we were talking about, that's where we're going to see some of the newest seafloor. So this ocean ridge is forming where plates are pulling apart, so divergent plates. And as those plates pull apart, new crust comes up forming this ridge, and that's going to be our newest crust. And that's what we're able to see here.
Yeah, I remember when I was first learning about seafloor spreading, or when I learned about it again, I kind of thought, and I think a lot of kids think about when the seafloor spreads apart, what you would leave is a hole.
Yeah.
But really, the pressure from underneath the surface of the ocean is actually higher, and it has all that magma in there. And so when you open up these holes, rather than making a hole that goes in, rather you have this magma and lava coming out, which makes these underwater ridges. But also these underwater ridges are really small volcanoes, right?
Yeah, absolutely. I think you're right that there can be a lot of confusion that where plates are coming apart, you're not left with a canyon. Instead, there's stuff coming up in between it. It makes for some really interesting seafloor exploration. As you mentioned, there's a lot of seafloor left to explore.
On this map, we actually have the plate boundaries. And so we were talking about the seafloor, how it moves and changes, but it really is broken up into these pieces, right? These tectonic plates. And they actually join where we've added these kind of black boundaries here. So you can really see the Pacific plate, which is underneath the Pacific Ocean, how it interacts with these other plates. And it's quite old. So it's actually going up under these other plates and being recycled and then making new plate.
And Hilary, what kind of activity do we get when you get a plate moving underneath another one? It's pretty exciting.
You get a lot of different activity. Yeah, so you can have islands form, which is why a lot of times your islands are going to be along some of these plate boundaries because they're volcanic areas, but also we get some pretty intense earthquakes. So we're going to load, and in your version here, these are going to be just together. So what we're loading here is deep sea vent locations along with volcano locations. So the triangles are volcanoes and the stars are vents. Can you tell us what a vent is?
Yeah, so a deep sea vent is where seawater has seeped down beneath the sea surface, heated up, and now is shooting up into the ocean. Really hot, chemically rich water. Since 1977, scientists have discovered over 240 deep sea vents. And it turns out with this really warm water at the bottom of the seafloor where it's normally really cold and all the different chemicals that are in them, there's really interesting life forms that can be found around these vents. So they're super fascinating to scientists. And a great place to study. And so we're still working on finding more. We know there's got to be more of them, but first one found in the 70s, and now we're up to over 200 so far, and we're learning a lot through them.
Yeah, and a lot of these, some of them are animals, some of them are plants, but they use chemicals. It's like the plants, instead of photosynthesis, I think it's called chemosynthesis, and they use the chemicals because it's so dark at the bottom, so that they don't actually use light and produce food through photosynthesis, but rather through chemical food. So that's pretty amazing. So what you can see when you put these together is a lot of times they're kind of matching up. Certainly you would see, if we were to put earthquakes on top of this, you would see that they definitely match up with earthquakes as well, because really it's these plates and it's at those boundaries where you get this kind of these disruptions and these really neat, fun activity. Fun being the vents.
Yes.
And the amazing animals.
The other thing we can get at these boundaries, we've mentioned the volcanoes and the vents. The next is earthquakes, and we've mentioned that. But under the ocean, when you have an earthquake, what that can trigger is a tsunami. So what Hilary's going to load up next for us is a model of a tsunami that happened in May 1960. This earthquake is the strongest one recorded on Earth. Is that right, Hilary?
Yeah, I believe that's right. And ever recorded, of course, there are earthquakes that we can surmise from geologic record that have happened earlier than that. But this is certainly, as far as I know, the strongest earthquake ever recorded with instruments. And so I believe it was a 9.5, which is crazy big, right?
Yeah. So what we're looking at here is the propagation of the tsunami wave after the earthquake happens. So an earthquake under the ocean happened, it displaces the seafloor, which causes a wave. And one misconception about tsunamis is that it's just one big wave. And it's actually a series of waves that's moving at the speed of a jet plane. And in the Pacific Basin, these waves will travel all the way across the Pacific Ocean, impact the other side of the world there. They can be devastating. So NOAA has a tsunami warning center, well, a few throughout the Pacific there to help keep our citizens safe, and other countries have similar things.
Yeah, and actually, this is a really impactful tsunami and earthquake. But the one that happens in this area here, which is the Sumatra one, which you can pull up in your app as well, I believe. If not, we'll put it right in there. The Sumatra one was the one that really caused just a devastating loss of life. And so ever since then, we have added tsunami buoys in areas that are close to convergent, which would be the plates that move towards each other. So convergent plate boundaries where there's large earthquakes. We have, us and other countries have added these, they're called DART buoys. And they're actually tethered to the bottom of the ocean and can detect the pressure difference. Because if you were out in the middle of the Pacific here during this tsunami, you would never know, because the frequency, the length of this wave is so long that the amplitude is actually quite short in the middle of the ocean. But then when it hits land, it sort of crunches and moves up.
Yeah, absolutely. So it's really fast, really long out in the oceans, and it slows down, builds up, gets tall along the coast, and that's where it can do a lot of damage. Certainly, if you're ever on the coast and you feel an earthquake, the best thing to do is to get to higher ground.
And an important thing is to stay at higher ground for a long period of time. Let me just back up just a little bit, and I just want to show you what happens when the tsunami hits, for example, comes across Hawaii and some of these islands, and this shading, this light colored shading, is actually those ridges or high points in the ocean floor. And you can see what happens when it comes across these areas. It starts to ripple. You can have echo waves, they're called, so subsequent waves after the first one. And so there definitely have been some terrible situations where echo waves have caused a lot of damage. So yeah, you see the water go away, which is a common thing that happens. You see the water just go away and you're playing in the ocean. You want to run away from the ocean, get to higher ground, and stay at higher ground for a while, for a couple of hours.
Absolutely. There's so many things that we could talk about when we discuss the oceans. And I think this is a great one because it's a safety issue. So I want to thank you for joining us today on World Ocean Day. Download the app, play with it. There's a ton of ocean data sets to explore. You can learn more, and stay tuned because we'll be doing more of these.
Absolutely. Thank you.